Hey guys, in this video we're going to be covering activity 4D.2. Our master learning objective is I can solve real-world quadratic equations by using the area model. So before area, we're dealing with rectangles. Area is talking about our length, right? You can say area, which is represented by A, is going to equal our length times our width. Alright, length times our width is going to be our area. So all of these, we're going to be setting up problems kind of like our previous unit, where we're reading what each side is, and we want to go ahead and figure out what our length and what our width is. So don't forget, we're dealing with a square or rectangle, it's always length times our width. So first example, says a rectangle has side A with an unknown length. If side B is 9 inches less than side A, create a quadratic equation that calculates the area. So the first thing is we're going to draw a picture. So I have some rectangle. Alright, it tells me that I have a rectangle that has side A with an unknown length. So I don't know what A is. I'm just going to go ahead and leave that be X. And then if side B is 9 inches less than A, well, 9 inches less than A. Less than means subtract. So I know I'm going to be subtracting 9, but what was A, we don't know. So whatever A was, we want 9 less than that. So it's going to be X minus 9. Step 2 is write the equation. Well, the equation is just our area equals length times our width. So our length, doesn't really matter which one we say. So we say X, our width would be X minus 9. And this is going to be equal to A. If it just asks you to write the equation, no need to go ahead and solve. All you have to do is write me the equation. Example number 2. The rectangle has side A with an unknown length. So I have some rectangle. We don't know what A is. We don't know what A is. And side B is 4 inches longer than side A. So 4 inches longer than side A is going to be whatever A is. Longer means add, right? So longer here means add. Less than means subtract. So again, write our equation here. We know area is going to equal our length times our width. So it's going to be X times X plus 9. Alright, again, all it asked us was to write the equation. We don't need to solve or simplify yet. Looking at example number 3, it says now we have a farmer who's fencing a rectangular area. He plans to enclose an area that is 48 meters squared. Using fencing on 4 sides, the length is 2 meters longer than the width. Step 1 says draw a picture. So, draw a picture. Some things that we know is that the area is 48. Right? We know that's what it is. The other thing that gives that away is that meters squared. So anytime you see units squared, that's always going to be your area. Right? If it was units cubed, it would be volume. So let's go ahead and look at what each side is. It says that we have the plans to enclose this area. Got it. The length is 2 meters longer than its width. So we don't know what the width is, right? So that's just going to be X. And then if our length is 2 meters longer than that, longer means add 2. So whatever the width was, we need to add 2 to it. All right, step 2 is asking us to, well, let W represent the width. Write an expression for the length. Alright, so what we're going to do here is I'm actually going to go ahead and change my X's and change them to W's. So let me change that really quick. I'm going to say this was a W, and this would be whatever that width is plus 2. So that when we look at step 2, it says let W represent the width, which we already did. Right, that's what we have in red. Write an expression for the length. Well, the length is just going to equal W plus 2. So you can say that L is going to equal W plus 2. All right, step 3 says write an equation to represent the area and solve for the width. So remember, area equals length times our width. What was our area? Our area was 48. Our length was W plus 2. Our width was W. And we can go ahead and solve. Distribute. Right, so we're going to have 48 equals. I'm going to go ahead and distribute. W times W is W squared. W times 2 is 2W. Alright, from here we want to be able to solve. So we're looking for what W is. So we need this equal to 0. So what we have to do is we have to subtract. I'm going to subtract 48 over to the other side so that I get a 0. And I'm going to go ahead and scroll this over a little bit. So what we have here is 0 equals W squared plus 2W minus 48. Alright, now we need to factor it. So this is where kind of you get to do whatever you want. If you know how to factor without doing the Punnett square box. Otherwise, our Punnett square box, we're always going to take that last term and put it in the bottom. So again, this should be more of a refresher than learning it for the first time. So that bottom term is down here. And that's whatever we multiply to. Right? We multiply to negative 48. Our W squared just gets brought down in the top left. And we're looking for whatever adds to 2W. So if we're adding to 2W and multiplying to negative 48, yes, you can use your power cheat sheet. Our two numbers that we're going to be looking for then are going to be, looks like 8 times the negative 6 gives me my negative 48. That's good. And then 8W minus 6W would give me a positive 2W. So those two numbers are going to be what I place on the side of my Punnett square box, right? These numbers right here is going to be a positive 8W and a negative 6W. So therefore, I'm going to have a negative 6 and a positive 8. This is just our W times our W. So 0 is going to equal W minus 6 times W plus 8. I still have to go ahead and solve each of these, set each of them equal to 0. So therefore, W would equal a positive 6 and W would equal a negative 8. Hopefully you remember, though, that when we're dealing with real-world problems, we can't take negative answers. So we're going to exclude the negative, and our answer for our width is 6. Right? So therefore, we know that our width is going to be 6. Asks us to solve for our length. Well, previously we said that our length was, right next to it is whatever W is plus 2. So our length is going to be our width, which we just said is 6, plus 2. So our length is going to be 8. Right? So our length is 8. We could put units on here. So therefore, length is 8 meters and our width is 6 meters. Okay? We're going to go ahead and go on to the next example here. Example number 2. A farmer is fencing a rectangle area he plans to enclose. And our area this time is 45 meters squared using fencing on all 4 sides. The length is 4 meters shorter than the width. The first thing is draw a picture. So we have a picture. We know our area is 45. We know this is meters squared. Our length is 4 meters shorter than. So shorter than means subtract. So if I have this as our W, W, we don't know what the width is. The length is whatever W is minus 4. Alright, so step 2 says let the width, W equal the width, and express for our length? Well, our length is just going to equal W minus 4. We already discussed that. Looking at step 3, it's asking us to actually solve for W now. So remember, we start off with our area formula. Area equals length times width. Our area is 45 equals our length, which is W minus 4, times our width. If we go ahead and distribute, W times W is W squared. W times negative 4 is negative 4W. If you need to use the colors, feel free to use the colors. I'm going to go ahead and subtract 45 on each side because I need this equal to a 0. So I have 0 equaling W squared minus 4W minus 45. Now this is what I need to factor. So I know I'm going to have my negative 45 in the bottom right. I'm going to have my W squared up here. And remember that I multiply. This is what I'm multiplying to. And then I add to a negative 4. So what number multiplies to a negative 45 but adds to a negative 4? And our two options for that would be, if you use your multiplication chart, we'd have a negative 9 and a positive 5, right? Because negative 9 times 5 is a negative 45, and negative 9x plus 5x, or this would be W, right? W, that would equal a negative 4W. So those are going to be our two terms that we're going to use in our diagonal. Is that negative 9 and that positive 5. So negative 9W and positive 5W would give me a plus 5 here, and a plus and a negative 9 at the top. Alright, so this is going to be W and W. Therefore, this is just going to equal W minus 9, W plus 5 equals 0. If we set each of these equal to 0, we get W equaling a positive 9 and W equaling a negative 5. Right? Take the opposite. But again, real world problem says that we cannot use the negative answer. So we're going to exclude that negative 5, and our width is going to be 9 meters, asking us to solve for the length. So if our length was W minus 4, so our length is going to equal W minus 4. We plug in that W there. Our W was that negative, or that positive 9. So 9 minus 4 is 5. And it would be 5 meters. So our length is 5 meters. Our width is 9 meters. Alright, so again, draw yourself a picture, get everything over to one side, factor, only take the positive answer, and then go ahead and substitute it back into the other equation. Next example here. Again, our farmer now, he's still fencing in his farm. We have 44 meters of fencing, and our length is 4 meters longer. 4 meters longer than the width. So longer means add. Alright, so our picture here, our area is 44 meters squared. We know we have some width, and our length is going to be whatever the width is plus 7, right? Because longer than it means plus 7. So step 2 says, well, let W represent the width, express the length. So our length is going to be whatever our width is plus 7. Alright, step 3, set everything up. So area equals length times width. We know what the area was, that was 44. Our length was W plus 7, and our width was W. If we go ahead and distribute that, 44 equals W times W is W squared. W times a positive 7 is 7W. I want to make sure that this is equal to 0, so I'm going to go ahead and subtract 44 over to the other side. So 0 is going to equal W squared plus 7W minus 14 now. That's what I'm going to use to help me figure out what my Punnett square box is. So I have negative 14 down here. I have my positive w squared up there. And I'm looking for something that multiplies to negative 14 and adds to a 7. So the two numbers that I'd be using there would be a positive, oh, it's not a 14, it's a positive 44. My apologies, guys. So when I subtracted 44, this should be a negative 44, right? I accidentally wrote a 14, forgot to write the little sign. So it's actually a negative 44. So what multiplies to a negative 44 adds to a positive 7. So only two numbers that would do that would be a positive 11 times a negative 4, right? That would still give me a negative 44, which I need. And then if I had a positive 11w minus 4w, that would equal a positive 7w. So I'm going to use a positive 11w and a negative 4w. So that would make this a negative 4 and a positive 11, which would give me then w plus 11, w minus 4, still all equal to 0. W equals a negative 11, w equals a positive 4. So again, we can't take the negative answer, we can only take positive, so I'm going to exclude that negative 11, and the only answer I could use is 4, and this is in meters. So my width is 4 meters. I take that back to what my length was. So length, my length is going to equal w plus 7. So my w was 4, and then I'm going to go ahead and add 7. So 4 plus 7 is 11 meters. Okay, that brings us to the last video of this unit, guys. So there is a test review. So you can work on not only the activity for 4D.2, check that in, and then you work on that test review. And then after that is just our final reviews. All right, good luck, guys.